all the way around a circle. If I tell you I don't want to go around a circle the entire length all the way around it, I want to go a certain number of degrees, like 120 degrees worth. I'm just going to go this much of the path around. So I'm still going to use this idea of following the circumference, but I just want to say whatever that whole circumference is, I just want a percentage of it. Well, the percentage is going to be just whatever number of degrees out of how many degrees in a circle. So all we're going to do today is play with circumference and a percentage of that number goes in front of it. The percentage is going to be 120 out of 360, or 1/3 of the answer. The same thing for area. If I wanted to find the area of this, I love pie. I think I could eat 1/3 of that pie that Grandma made. So instead of figuring out the entire pie, I just want to figure out how much of that crust on the top, what area does that represent? Well, I'm going to find the entire area. Pi times radius times radius. You'll see pi times radius. It's the entire thing, but we just want a percentage of it. So I need to know the radius, but I also need to know how much of the angle out of 360 am I playing with. You have a chance to go back to that later. Let me have everybody turn off their homework. I'm going to give you a chance. You're going to have more than a half of an hour to get back to your homework. But if you don't play this game, you're not going to be okay with the second. You're going to be hurting for the second homework. If you're into using colors, I think I've got a 2-color combination. I'm going to use 8 of today's new package. So this is what we talked about just a second, what I just had up on the board that you copied. This is going to be the percentage. This is going to be the entire circumference. In this first example, I don't want to do part 3. I do want to do part 1 and part 2. We're looking at the side of a globe. So we're only looking at the 3-dimensional shape from a 2-dimensional perspective. But if this is the equator, and they're saying this is 12 degrees, this is 12 degrees, and this is 38 degrees, how do I find how many degrees between the two of them? Add them together. 12 and 38 is 50.95. And that's the first question's answer. Find the angle at the Earth's center between the radius drawn to Washington, D.C. and Lima, Peru. So if we were actually now going to talk about the length of this part of the circumference, that's called an arc length. the arc length is going to be the part of the circle we're interested in, which is going to be 50.95 out of 360 degrees, times the formula for the whole thing. In fact, if I do this ahead of time, if I do 50.95 divided by 360, we're saying that it's only going to be about 14% of the circle. Now if I multiply that with 2 radiuses, and they tell me up here in the question that the radius is 6,370 kilometers, 2r times pi. So here's the overall circumference. So we're going to take 14% times the formula for the whole circumference. 2 times 6370 times pi and the distance that this red arc length represents is about 5,600. The only units we're talking about are kilometers. So it's everything that you did in the homework assignment that's due at midnight tonight, and then we just have to add the percentage of the circumference to it. Go to the back of this page, page 9. I'm waiting.
I'm still putting this on the internet.
That'll give you the diameter, and then you divide it. Yeah, but you're trying to find the radius.
No, you divide the diameter by.
Okay.
So I'm here in my Canvas account. If you go to circumference, we've already played with circumference and area. By the way, in chapter 11, the entire package again is up here. The full package. The calendar all the way to the end of the chapter. Every one of these days has been put all together in one big file right here. But if you go into today's, this is the handout. You're going to see the notes after I finish today. I'll put the notes, my handwritten notes up here. But I also have some videos that I can show you. You can go back if you're absent. Like Lorenzo's saying, should I get points taken off for being absent? You should be able to stay up with the class by watching and learning and teaching yourself.
And we've seen that, in fact, we compute the measure of an arc, which actually is identical to the measure of the central angle. And that measure, of course, is a bit different. But there's something else we can do. You can think about this arc as actually being a little thing made out of some kind of length of rope or some kind of thing. And we can actually ask for its exact length. If I were to take a ruler and somehow measure it, it'd be hard to do. It might be easier to take a rope, put it against that arc, and then straighten it out, and then measure that. That actually finds the length of the arc, which is sometimes referred to as, not surprisingly, the arc length. Now, arc length actually can be found in the exact analogous way as the area of a sector, let's think about arc length now. We know that if we go once around the circle, the arc length of that is exactly the circumference, which we know is 2 pi r. So if you want to figure out the arc length of just a part of that, well then you have to find the appropriate fraction. And so the formula for arc length is actually pretty easy. It's just 2 pi r, which is the formula for, the entire.
How is his
arc
formula
length
different than ours?
Circumference. And then multiply by the
You're
fraction.
using m instead of the
This
word
can
what?
actually work.
Degree, and he's got the fraction, the percentage behind the formula, but it's the same thing, isn't
Divided
it?
by 360. So again, it makes a lot of sense when you just think about it. Let's take a look at an example together. So let's suppose that we want to find the arc length of an arc that has a measure of 40 degrees in a circle with radius 6 inches. So how do we proceed? Well, we use the formula. So we know that we have a radius of 6, so I have 2 pi times 6, which is 12 pi, times, now I gotta figure out the appropriate proportion, which is gonna be 40 divided by, appropriate ratio, I should say, 40 divided by 360. So what does that work out to be? Well, that works out to be 4/3 pi. What are my units here? Well, this is now a length, and it's measuring a length as if we were putting a ruler against it, and so my units are inches, not degrees, that's the measure, but here,
Can you stop, open up your calculator and just put in 12 times 40 divided by 360? You're gonna get a decimal, aren't you?
Yes, 1.3.
What? 4 divided by 3?
Well, I want the numbers there. 12 times 40 divided by 360.
1.333333 repeating.
So how did he get that fraction? So here's the number that Aiden's saying, 1.33333. If you use this math feature and change it into a fraction, the very first feature,
4/3.
take the answer and change it to a fraction, I hit enter to actually perform it. That's how he got 4/3?
I got it.
4/3.
I thought it, so you don't put it in parentheses? Because I got 4.1. 4.1.
So what did you want to put in parentheses, Hannah?
40 divided by 360.
You could, so you said 12 times in
Oh,
parentheses.
12 times? I thought you said 12 times.
12 times.
Oh, okay.
So we still have pi in the formula, not in the
Am I
calculator.
supposed to do something after I do that?
Oh, okay.
with arc length, we see is 4/3 pi inches. And now we can see exactly how to compute the length of not just the entire.
Now this doesn't make sense to me. I have no clue how big this is as far as the number of inches. So I would then say, take this number and multiply it by pi, and that'll give me an actual value. So that length of rope that he was talking about is 4.2 inches long. I don't know what 4/3 of a pi is, but I know what 4.2 looks like. All right, go to the back page, page 9. Two examples here. We're going from 12 o'clock to 12:30. How many minutes is that?
30 minutes.
30 minutes. How many minutes are there in an hour?
60.
So if we're taking this clock and we're wrapping around with the minute hand until we get to 12:30. We could say 30 out of 60 minutes. We don't necessarily have to play 360-degree games. We're just looking for a percentage of the overall circumference. This is a shortcut. Would you agree that that's half of a circle? 30 minutes, looks like we're going halfway around. If there was some ink spilling out of the tip of this minute hand